Hello students, I am Kausalya. Today we are going to solve the next part of example 1.8. That is, we are going to draw the force voltage and force current electrical analogous circuit, and also we are going to write mesh and nodal equations. So this is the given problem, and from this problem we had obtained two equations, namely equation A and equation B. That is, everything is represented in terms of velocity here. So with the help of these equations, we are going to write force voltage analogy first and then force current analogy later. So first, so from the expression 1 and 2, just list out what are all the elements present here. That is, we are having M1, we are having B1, we are having B12, K1, and also M2, B2, K2, K1 and B12. So in our force voltage analogy, we had seen previously, that is M will be represented as an inductor, that is M gets modified as L, and K will be represented as capacitor. So here I am writing it as 1 by C because we will write the expression in the form of 1 by C. So here K gets converted into capacitor, and again this dashpot B gets converted into a resistor. Right. Since this is a force voltage analogy, here the input force will get converted into a voltage. So from the first equation we are having f of t, force. So this force will be converted into a voltage here. So that is E of t. So V1 gets converted into I1 and V2 is represented as I2. Now I am going to write the remaining terms which are present in the equation. So this is a general form of representation, M, K and B. Now I am going to represent, we are having M1. So M1 is represented as L1 and again M2 is represented as L2. Right. And the next one is, we are having B1. So B1 is represented as R1 and B2 is represented as R2. And apart from that, we are having B12. So this B12 is represented as R12. And the next one is, we are having K1 and K2. So K1 is represented as 1 by C1 and K2 is represented as 1 by C2. Okay, hope you all are clear with this. If you have any doubt, kindly refer my previous video where I have discussed in detail about force voltage and force current analogous circuits. So now I am going to draw the equivalent electrical circuit here. So just consider your equation 1. Here we are having an f of t, right? This f of t gets converted into, that is, it is represented as an E of t in the force voltage analogy. So first I am representing a voltage source here. So this is your E of t. And the next one is, you are having an M1 which is related only with the V1, right? So M1 gets modified as L1 here. So just draw L1. This is your L1, right? And the next one is, you are having a B1. Again B1 is related only with V1 here. So B1 is represented as a resistor R1. So just draw a resistor here. This is nothing but your R1, right? And the next term is B12. This is common to both V1 and V2, right? So here, this is the part of the loop which is common to your loop 1 and loop 2. So here we are having B12. This B12 is represented as R12. So just draw R12 in the common part. This is your R12. And the next one is, you are having K1. Again this K1 is common for V1 and V2. So this K1 is represented as 1 by C1. So here just draw a capacitor C1. Right. So this is our first loop. So in first loop we are having a flow of current that is represented as an I1. And again this voltage source is represented as plus minus, and current always flows from minus to plus. Right. And now we are going to draw our second loop. So while considering the second loop, again we are having M2 here. Right. M2, and this M2 is related with only V2, that is with loop 2. So this M2 can be represented as, M2 is represented as L2 here. So just draw L2. This is your L2. And the next one is, here we are having a B2, and this B2 is related only with V2. So again B2 is nothing but it is represented as R2. So just draw a resistor here. This is nothing but your R2. Then the next one is K2, and this K2 is related only with V2. Right. So K2 is nothing but 1 by C2. So just draw a capacitor C2 here. This is our second loop, and I2 is the current which is flowing through the second loop. Hope you are clear with this, right? If you have any doubt, just let me know in the comment section. And the next one is, we are going to consider our loop 1. So just draw the loop 1 as such. We are having an inductor L1, and I am having a resistor R1, and again I am having a resistor R12, and finally I am having a capacitor C1 and a voltage source here plus minus, and this is represented as an E of t, and I1 is the current flowing through the circuit. Right. Now I am going to write the equations for this loop. So here the supply voltage is E of t. Right. So I am going to apply Kirchhoff's voltage law, that is KVL. When you apply Kirchhoff's voltage law, here this is your input voltage source. So this input voltage source E of t will be equal to the respective voltage drop across each elements here. So the voltage across an inductor is given by L1 into dI1 by dt. Right. Plus voltage drop across the resistor is given by I1 IR. Here the current flowing is I1. So here I am writing it as I1 R1. Plus again here I am having R12, and this R12 is common for both loop 1 and loop 2. So here the current flowing is I2. Right. So this is common for the path of current flow I1 and I2. So here I have to write it as R12 into, since I am considering first loop, the current flowing through the first loop is I1. So I have to write it as I1 minus I2. Plus again while writing the equation for the capacitor, 1 by C1 into integral of, again this C1 is common for loop 1 and loop 2. So here I am writing I1 minus I2 into dt. This is our respective expression for loop 1. That is, we are having a voltage source. This voltage is equal to the, this source voltage will be equal to the voltage drop across each element in that loop. Right. So totally we are having 1, 2, 3, 4, 5 elements. So your expression should also consist of 5. That is, your expression should consist of 5 parts. 1, 2, 3, 4, 5. Okay, kindly make a check of it. This is your equation number. Let me keep it as sum p. Right. The second one is, now we are going to consider our loop 2. So again in loop 2, just from this expression we are having, that is, we are having 5 elements in loop 2. Just let me draw these 5 elements here. So this is your L2, Okay, this is our loop 2 and I2 is the current flowing through it, and here current I1 flows. Now I am going to write the voltage equation here. So here there is no source voltage, right? So by Kirchhoff's voltage law, the source voltage is 0 here. So the remaining things are voltage drop across each and every element. So just consider L2. Through this L2 I am having only the current I2 which flows. So this is represented as L2 into di2 by dt, plus again current flowing through this R2, so I2 into R2, that is voltage drop across R2, plus again voltage drop across capacitor, that is represented as 1 by C2 into integral of I2 into dt, right? Plus now consider your resistor R12. This is common for both I1 and I2. So R12 into, now I am considering loop 2. So in loop 2 the current I2 flows. So here I have to write it as I2 minus I1. Plus again we are having another capacitor which is common for both loop 1 and loop 2. So I am writing it as 1 by C1 into integral of I2 minus I1 into dt. Okay, this is the respective voltage expression for this equation, for this loop. This is the respective expression for this loop 2. Hope you understand this concept. In the next video, let me explain about the force current analogy.